Good morning. Today we're going to discuss about our first module, electrochemistry. Electrochemistry is a separate branch of chemistry which mainly deals with redox reactions. So electrochemical cells. So electrochemical cells are the cells where chemical energy is converted into electrical energy and vice versa. Vice versa means where electrical energy is converted into chemical energy. So, electrochemical cells are the devices wherein chemical energy is converted into electrical energy and electrical energy is converted into chemical energy. So, we have mainly two types of electrochemical cells. They are galvanic cells and electrolytic cells. So, the devices which convert chemical energy into electrical energy with redox reactions are called as galvanic cells. So example for your galvanic cells are Daniel cell, right? So all the reactions, so our everyday batteries when your clock is running, so that also will act as a galvanic cell, right? So next, electrolytic cells. So here, the device which converts electrical energy into chemical energy is called as electrolytic cell, or any reactions by the virtue of electrical energy if some chemical changes occur. Okay, so by virtue of, that is by applying some electrical current, if some chemical changes occurs, then such type of cells are called as electrolytic cells. Example are our electrolysis process. So let us see the differences between galvanic cells and electrolytic cells. As discussed earlier, the galvanic cells are the cells which convert chemical energy into electrical energy. Our electrolytic cells are the cells which convert electrical energy into chemical energy. So in galvanic cells, anode is positive, whereas electrolytic cells, anode is negative. In galvanic cells, anode is cathode is positive, negative. Electrolytic cells, cathode is positive. Here, the galvanic cells reactions are spontaneous, whereas electrolytic cells requires a source of electrical energy to carry off non-spontaneous redox reactions. So, example for galvanic cells, batteries. So, when you're using batteries in the sense, so cells, dry cells. Okay, so the clocks in clock or calculators, the cells which we use, so use and throw. So those are example for your galvanic cells. So electrolytic cells, the electrolysis process is the best example for your electrolytic cell. And here secondary batteries, when you are recharging the battery, it is a electrolytic cell. So battery is the best example for both galvanic cell and electrolytic cell. So in a battery, when you are withdrawing the power, it will act as galvanic cell. When you are recharging, okay, when you are recharging, it will act as a electrolytic cell. So battery will act both as galvanic cell as well as electrolytic cell. So this the best example for galvanic cell is our Daniel cell. So Daniel cell is made up of two half cells. What do you mean by half cell? A metal dipped in its own salt solution is called as a half cell. We have two half cells, one is zinc half cell, other one is copper half cell. When these two half cells are coupled with a salt bridge and connected with a voltmeter. So when this zinc half cell is dipped in zinc sulfate will act as one half cell, copper dipped in copper sulfate will act as other half cells. When these two half cells are coupled together through a salt bridge and connected with a voltmeter, it forms a Daniel cell. So let us see, when these two are coupled, what are the chemical reactions occur, which is anode and which is cathode. When zinc is dipped in zinc sulfate, that is at zinc electrode, what will happen? Zinc undergoes oxidation. That is, Zn will lose 2 electrons to give Zn2 plus. Okay. Whereas at copper, Cu2 plus will accept 2 electrons to give you Cu metal. Cu metal will get precipitated. So Here, since zinc loses its electrons to give Zn2 plus and 2 electrons, zinc electrode is termed as anode, and at copper, Cu2 plus will accept electrons and it get reduced to give Cu, it is called as cathode. As per IUPAC nomenclature, the electrode where oxidation occurs is given negative charge, and the electrode where oxidation reduction occurs is positively charged. Therefore, anode is negatively charged and cathode is positively charged. So in a galvanic cell, anode is negatively charged and cathode is positively charged. So what is oxidation? Oxidation is loss of electrons. What is reduction? Reduction is gain of electrons. So anode is negatively charged, cathode is positively charged. Okay. So what is charge of anode in galvanic cell? Charge of anode in galvanic cell is negative. Charge of cathode in galvanic cell is positive. Okay. So the overall reactions can be written. So next, using this, we are going to determine electrode potential. So what do you mean by electrode potential? So whenever a metal is dipped in its own salt solution, it has a natural tendency to either lose electrons or gain electrons, due to which metal gains a potential which is known as single electrode potential or electrode potential. So when, for instance, in our previous slide, we have seen zinc dipped in zinc sulfate, which forms a half cell, right? So when that half cell, when zinc is dipped in zinc sulfate, it's a half cell. What happens? Zinc will lose electrons to give you Zn2 plus, right? So because of that, what will happen? Zn2 plus will go into the solution, whereas electrons will get deposited on the surface of the metal. So because of this, there will be a solution, metal solution interface, right? There will be a metal solution interface. So electrons will be on the surface of the metal, whereas Zn2 plus will be in solution. So there will be a weak attraction between Zn2 plus positive and negative charges. Because of this, the electrode gains a potential, and that potential is called as or termed as electrode potential. So if the same potential is measured at standard temperature, pressure and at unit molar concentration, then it is termed as standard electrode potential, and it is denoted by E naught, capital E naught. Okay. So there are other terms which we are going to use frequently in this module are free energy and entropy. So the frequently used terms are oxidation, reduction, electrode potential, standard electrode potential. So you know what is oxidation? Loss of electrons is oxidation. Reduction, gain of electrons is reduction. So what is electrode potential? You know what is an electrode potential? We have discussed. Let us discuss what is free energy and entropy. So what is free energy? So any energy which can be converted into useful work is called as free energy. So energy in a substance is associated with definite amount of energy, which might be internal energy or it can be external energy. So the energy which is converted into useful form is known as free energy. So this energy, this free energy is given by, as per thermodynamics, G equals H minus Ts. That is, delta G equals delta H minus T delta S, where delta G gives free energy, delta H is enthalpy, T is temperature, and delta S is change in entropy. Okay. So if delta G, that is free energy change, delta G is change in free energy. If delta G is 0, then reaction is at equilibrium. If delta G is negative, then reaction is spontaneous. And if delta G is positive, reaction is non-spontaneous. This is how we'll decide whether reaction is in equilibrium or reaction is spontaneous or reaction is non-spontaneous, depending upon the Gibbs free energy value. Next, coming to entropy. What is entropy? So entropy is nothing but measure of randomness or disorderness of the system. So the randomness or disorderness will increase from solid state to liquid state to gaseous state, right? So now you understand what is entropy, right? So the entropy is less in state of in case of solid, whereas it will increase in case of liquid, and it will increase further in case of what, gaseous state. So if it is given by delta S, is represented by delta S and given by delta S equal Q by T. If delta S is 0, then it is reaction is reversible. If delta S is greater than 0, then the process is irreversible. Delta S, that is entropy value, is greater than, is equal to 0, the process is reversible. If it is greater than 0, the process is irreversible. Okay, that is randomness. If you take ice, randomness is less. If it converts to liquid, it will flow easily, right? So molecules are easy to flow. When you convert liquid water to vapor, water vapor, it is very free to move into the vapor. That is entropy. Okay, so thank you. So we'll discuss using these terms. We'll connect this to Nernst equation. So what is Nernst equation and what is it related? We'll discuss in our next discussion. Thank you.